We're looking at proportional reasoning, and we're going to use diagrams to solve this question. The overall expectation is to solve problems involving proportional reasoning. Specific expectation to illustrate equivalent ratios using a variety of tools. This one we're going to use diagrams. So let's look at our inquiry-based question. On a sunny day, a flagpole that is 6 meters tall casts a shadow that is 2.4 meters long. At the same time, the tree beside the flagpole casts a shadow that is 4 meters long. How tall is the tree? Okay, let's highlight our important information. A flagpole is 6 meters tall. Okay, casts a shadow that is 2.4 meters long. At the same time, a tree beside the flagpole, so this is beside it, okay, casts a shadow that is 4 meters long. How tall is the tree? Okay, so we can kind of set these diagrams up in several different ways. One way is very straightforward. Here's our flagpole. Here's our shadow, right? And then maybe here's our tree, and here's his shadow, which is a little longer. Remember, it was 4 meters rather than 2.4 meters, okay? With all the things being the same, what these are, we've built our similar triangles, okay? And because they're similar triangles, I'm going to show us another way we can kind of look at this diagram, okay? I want you to think like both shadows end at the same spot, and that same spot happens to be where you are. Okay, so there you are. Both the shadows end there, so the flagpole we'll say is closest to us, and the tree is a little farther away. Okay, what we'll do is set up, here's our tree, here's our flagpole, and what we'll notice here is our shadows go all the way to there. Okay, so I'm at the end of of course the green we should label, this is our tree, this is our flagpole, okay, and they're going to take an angle down to here, so I'm just going to kind of do this. Because they're similar triangles, I have to adapt my diagram to fit. What that means is the angles in these are all the same, okay, and then finally obviously this angle is the same between all of them. Okay, we know that the shadow length of the flagpole, which is right here, is 2.4. Now this is not drawn to scale, obviously, because the height of this object is 6 meters, and 6 should be much longer than our distance here. I've drawn it just to use up most of the page. They've also told us that the shadow of the tree, okay, is 4 meters in length. Okay? And what's unknown is the height of the tree. That's our x in this case. So there's a couple different relationships kind of going on here. What we can look at, one of them, is the setup of our diagram is that some number, okay, because these relationships are the same, we can use some number to go from 2.4 to 6. And that same number will take us from 4 to our unknown x, okay, some factor. And because we're increasing this relationship, means we're going to be multiplying by some value. So with our arrow here, what's happening is we're taking, we're going to take the larger value and divide by the smaller value, and it'll tell us what factor we're increasing by. Essentially, in terms of, if you're going to take an arrow and saying I want to go from here to here, but I want to know what to go up by or what to multiply by, we take our ending number, which in this case is our 6, and we divide by our start number, and that'll give us our rate. Okay, so our ending is 6 and our start is 2.4. If we divide those with calculators, 6 divided by 4 is 2.5. So that means we need to multiply by a value of 2.5. So with that being said, we should be able to take our 4 and multiply by 2.5 to take us to our height of our tree. Okay, so we'll test that out. 4 times 2.5 equals, and we'll take our calculator to test. 4 by 2.5, 10. So apparently the height of this tree is 10. Now with that same diagram, I know it's hard to see, I'm going to redraw it very quickly. Here's our flagpole, our tree, and here we are. I want to show you with this same relationship how we could have got, we could almost use another scale here with this diagram, okay? Okay, so again, here's our flagpole, here's our tree. Our tree's height is the unknown, but we do know the length of the tree's shadow is 4 meters. And we know the length of the shadow of the flagpole, okay, is 2.4, oops, that should be a 4. 2.4 meters. We know the height of the flagpole is 6 meters, okay? So, the last one we went from here to here. Another thing we could do is take the related sides. And what we mean by related sides is I mean this side, okay? So, and this measurement, those are our shadows. And find out what factor, the concept takes us from this value to this value, again multiplying by some increasing relationship, and then apply it to our other sides, the height of the flagpole and the height of the tree, and use that same factor to get the height of the tree. So, same idea as before. We take our ending number, divide by our starting number, okay, and we take our 4 divided by 2.4. What will that give us in this case? Well, 4 divided 2.4, 1.6 repeated, okay, 1.6. We want to be as accurate as possible, okay, so when we multiply this, I want to take this value to as many 6s as possible. So in my calculator, luckily, I can keep the old value. And yours, try to go as many places as possible. Times, and we're going to multiply the height of the flagpole. And that should give us the height of the tree, and the height of the tree again is 10. And look at that. So in this diagram has set us up to essentially solve this 2 different ways. Okay, so the height of the tree, x again, was 10 meters. If you'd like to look at other ways to solve this question, you can check out our other playlists on proportional reasoning.